All right. Report number 0116 M8718 for tactical trailer 22.5 pound payload capacity to TP9401 transportability testing procedures. Part 1 Introduction. Background. The U.S. Army Defensive Ammunition Center of the Validation Engineering Division was tasked with the program manager medium tactical trailers to conduct transportation testing on the M8718 for a tactical trailer. The trailer was manufactured with the Fountain Line trailer, Princeton, Kentucky. The trailer was tested in accordance with the TP9401 transportability of testing procedure. B. Authority the test was conducted by the IAW mission, responsible delegated with the U.S. Army Operations Support Command, Rock Island, Illinois. References made to the following: AR 740. 15 June 2001, storage and supply activity operation, IOCR 1023, mission major functions of the USA DAAC, January 7th, 1998. The objective of the testing determined that the M87-1A3 trailer was adequate with the transfer of ammunition for the road and rail. The trailer was rail impact tested upon using both a trailer on flat car, railway car, and a trailer with a flat car with chains. The test load included an intermodal opening container for the MLRS pod, intermodal opening container within 15 separate loading projectiles, brake bulk cargo load at 15 SLPs, and 105 box ammunition. Our conclusion: based on the review of the testing of the M87-1A through a trailer as the design, tested, and adequate, not ideal for the transfer of ammunition, several recommendations of improvement were discussed during the evaluations and listed in the abstract. Alright, Part 2 Attendees. The data performed in October 29th through the November 8th, 2001. Our attendee, Philip Barrickman, General Engineer, Mailing and Stephen Ballham, Maintenance System Manager. Michael Allen, Quality Assurance. Nicole McGriff, Vehicle Product Engineer, Intern. Testing equipment: semi-trailer load bed 22.5 model M87-1A3, manufacturer Fountain Line Trailer Company, Princeton, Kentucky. Date of the manufacturer August 2001. VIN number 13N2412AX1599605. Gross vehicle weight rating 61,700 pounds. Empty weight 17,500 pounds. Length width 41 feet and 3 inches by 96 inches. Tractor trailer model M1088, serial number T011181 BDK, and NSN 2320-01-355-4332. Weight 19,160 pounds. Length of 281 inches. Width of 96 inches. Height of 112 inches. Trail line flat car. CNWS 80784, built November 71, limited weight 4,607 pounds, loaded limited weight 70,000 pounds. Length 50 feet and 50 and a half feet by tractor trailer on flat car, rail car, CNNW 7805716, built July 1975. Limit weight 46,200 pounds. Load limit 70,000 pounds. Length 50 feet, 50 and a half feet. Flat car ITTX 972-861. Built June 1970th. Limited lightweight 78,000 pounds. Load limit 142,000 pounds. Length 89 by 0.3 feet. Equipped with 56 chain size of a half inch. Working load limited 13,750 pounds. Minimum braking load limited 55,000 pounds. Intermodular container MLRS pods. Dated manufacturers February 1990. Manufacturer J.D. Bertolini. ID number USAG 606 06579. Maximum gross weight 44,800 pounds. Tare weight 5,000 pounds. Intermodular container with separate loading projectiles. Date manufactured December 1996. Manufacturer CM. Cargo container limited company limited ID number to MLCU 3211090. Maximum gross weight 62,200 pounds. Tare weight 4,850 pounds. Part 4 testing procedures. Test procedure outlined in this section was distracted with the TP9401 with the transportability testing procedure, July 1994. Validation tactical vehicles outlined procedures using shipping ammunition with the tactical truck or rail car, and air non-explosive items were used with the build loads and brake bolt. Test loads brake was prepared with the bulk blocking and bracing procedures proposed from using the munitions sheet part 7 procedure. The procedure were used with the guideline with the tie-down position was adjusted with the accommodated with the tie-down ring spacing location on the M87-1A3 trailer. The weight and the physical characteristic weight, physical dimension, center line of the center or of gravity. The test load with a similar live explosive ammunition. The rail impact method. Load 87-1A3 was secured with the conventional friction draft gear with the non-cushion with the TOFC rail car with the cushion of the stanchion chain equipped flat car. The three chains were used with the per tie-down ring to secure the trailer to the flat car. The MTMCT pamphlet 5519 was used for the general guide with the unbuilt the wooden station required for the support of the trailer during the testing of the chain-equipped flat car. The modifications were required for the MTMC pamphlet designed to do the trailer kingpin height. The equipment needed to perform the testing included the specimen hammer of the car for the 4 empty railway cars connected together with the servant and anvil railroad locomotive of the anvil car with the position with the level section of the track where the air and the handbrake set with the draft gears compressed the locomotive unit and push from the specimen of the car toward the anvil and the predetermined speed. This is connected with the specimen car with approximately 50 yards away from the anvil cars, allowing the specimen car to roll freely along with the track until it struck the anvil. The constituted with the impact accomplished at the speed of 4, 6, or 8.1 miles an hour on one direction and speed at 8.1 miles an hour in the reverse direction. The tolerance and the impact speeds plus a half a mile an hour or minus 0 mile per hour. The impact speeds were determined by using electronic countermeasure of the time in the specimen car to transverse 11-foot distance immediately prior to the contact of the anvil car. See Figure 1. Figure 1 shows the railway car with the Association of American Railroad Standard Testing Plan with the distributed coupler, the timed interval of 11 foot, and specimen car. A buffer cars with the draft gear with the compressed with the air brakes on the set position. Annual car testing of the weight of 250,000 pounds approximately. The specimen car released by switching engine to the intent of the impact number 1, 4 miles an hour, and impact number 2, 6 miles an hour, impact number 3, 8.1 miles an hour. Then the car in the reverse is released by the switching engine to attain the impact number 4 of 0.1 of a mile per hour. B. Your hazard course. The load of the 87-1A3 was transported over the 200-foot-long specimen segment with the paved road consisting of the 2 series of the railroad ties projecting with the 6 inches above the level of the road surface. The hazard course was transversed 2 times. See Figure 2. Hazard 2 shows the hazard course stretch of the ties, the holder assembly of 5.1 foot 1, and the long, and also the details of the concrete surface over the rail. Number 1, the first series of the ties is spaced 10-foot centers alternately positioned opposite with the road line center with a distance of 50 feet. Following the first series of the ties, the paved roadway of 75 feet separate with the first and secondary series of the railroad ties. The secondary series of the ties is spaced 8-foot centers proportionally positioned on the opposite of the road center with a distance of 50 feet. Test load is driven across the hazardous course of the speed that it would produce the most violent vertical side-to-side rolling reaction obtainable in the transversing hazardous course approximately at 5 miles an hour. See the road trip. The loaded M87-1A3 the trailer was transported with a distance of 35 miles on the combination of the road surface with gravel and concrete. Asphalt test route included the curves, corners, and railroad crossing stops and starts. The trailer traveled at a maximum speed of the particular road being transversed except as limited with legal prescription. D. The testing was not required since the M87-1A3 trailer was rail impact tested. E. The washboard course of load M871A3 was driven over the washboard course at a speed that produced most violent response of the vehicle. Figure 3 shows the washboard course stretch between the concrete surface and the rail, and towards the top of the surface of the rail. Part 5 is a test result specimen M871A3 trailer. The manufacturer Fountain trailers may load inter-module container of the MLRS pods. Gross weight of 11,859 pounds. Testing date the 29th through the 31st of October 2001. The rail impact. Photo 1 trailer on the flat car rail impact testing M871A3 trailer. Description: flat car number CNW780784, 46,700 pounds. ISO container with the MLRS pods, 11,859 pounds. M871A3 trailer, 17,640 pounds. Total specimen weight, 76,199 pounds. Buffer car, cars, 4 cars, 250,000 pounds. Impact number 1, average velocity 4 miles an hour. 2, 6.4 miles an hour. 3, impact 3 number 8.1, and impact number 4, 7.9 miles velocity miles per hour. No damage excessive amount occurred with the flat car container of the twist lock during the testing. The test times of the impacts of 1 to 3 obtained with the stopwatch for impact 4. The electronic speed sensor was used. The impact 1 through 3 conducted with the rear of the train in direction of the impact. The impact 4 was the trailer front in direction of the impact of the trailer was impacted with the following removal of the rail car. The kingpin has sustained the galling of the flattening damage during the railway car impact testing. This due to the railroad stanchion locking nuts and held somewhere, which was prevented secure engagement against the trailer kingpin. The trailer was mission capable. Testing continued. Impact number 4 was not repeated to obtain an average velocity of 8.1 miles per hour due to the additional railway impact standards. Testing scheduled the TOFC trailer at fully payload. Photo 2 shows the galling of the kingpin. Photo 3 and also photo 3. B. Hazardous course dating the test in October 31st of 2001. Pass number 1, elapsed time 27 seconds. The average velocity of 5.7. Pass number 2, the 26 seconds elapsed time. Average velocity 5.9. 3, the elapsed time 27 seconds. The average velocity in miles per hour is 5.7. And also in pass number 4, 27 seconds with the average velocity of 5.7 miles per hour. The remarks: no damage, excessive movement occurred with the trailer contained with the twist lock during the testing. The trailer loaded was inspected found with each of the path. Velocity data represents the average velocity. C. The road trip, no damage, excessive movement occurred with the trailer container twisting locks during the testing. D. The panic stop testing was not required since the M871A3 was rail impact tested. The washboard, no damage, excessive movement occurred within the trailer or the container of the twist locks during the testing. Alright, 5.2 testing specimen M871A3 trailer manufacturer Fountain trailers. The payload intermodule container with a 15 mm separate loading projectiles in addition with 1 pallet MK82 500-pound bombs was secured against the trailer bulkhead. Gross weight of 45,180 pounds, 42,180 pounds container. The 15 mm SLPs plus 3,000 pounds for the MK82 bomb pallet. Testing data the November 1st, 2001. Rail impact. Photo 4 shows the trailer on the flat car railway impact testing of the M871A3 trailer on a fully payload. Photo 5 shows the trailer on a flat car rail impact testing of the M871A3 trailer full payload. Description: flat car CNW7801. 780,784, 46,700 pounds. The ISO container with the 15 mm SLPs, additional MK82 pallets of number 500 bombs, 45,180 pounds. M871A3 trailer, 17,640 pounds. Total specimen weight, 109,520 pounds. Buffer cars, 4 cars, 250,000 pounds. The impact number for number 1 was 3.7 miles per hour. The impact number for number 2 with the average velocity of 4.3 miles an hour. Impact number 3 was an average velocity of 6.2. Impact number 4 was 8.2, and number 5, C remarks 3 is 6.2. Remarks: the brake on the railway car did not fully release the impact. The rail crew corrected with the problem testing condition. The following impact with the twist lock door and the end of the container of the drive side with the jam would not freely turn freely. No damage was found on the twist lock container corner casting of the problem occurred due to the tolerance between the twist lock and the deck opening that allowed the twist lock to be pushed up with the cause it to jam. This did not affect the offloading of the container. The reverse 8 mile per hour impact was not performed. Inspection of the area and sanction kingpin locking plate revealed that a gap of 0 to 5 hundredths to 7 hundredths of an inch that was gap deemed excessive. Rail impact testing was discontinued and acceptable flat car provided with the rail carrier. The rail impact test retested results shown in figure 5F of this section. For the trailer offloaded the rail car with the preparation of the hazard course testing. The impacts 1-4 was conducted with the rear of the trailer facing the direction of the impact. No damage was excessive amount occurred with the trailer and container twist locks during the testing. 7. The velocity data represents the average speed during the testing. B. The hazardous course. Pass number 1, 31 seconds. The lap time 5 miles per hour. Pass number 2, 26 seconds. Lap time average velocity 5.9. Also number 3 was pass number 3 was 26 seconds. Lap time with the average velocity of 5.9 miles an hour, and pass number 4 was at 23 seconds elapsed time with the average velocity of 6.2. No damage, excessive movement occurred with the trailer containing the twist locks during the test. The trailer load was inspected following each of the pass. Following pass number 4, the twist lock of the nor the door of the container driver was sided jammed or would not turn freely. No damage was found with the twisted corner casting. The problem occurred with the tolerance between the twist lock deck opening that enabled the twist lock to be pushed up with the cause to jam. This did not affect the offloading of the container. 3. The velocity represents the average speed during the testing. C. The road trip. No damage, excessive movement occurred with the trailer container of the twist locks during the test. C. D. The panic stop. Testing was not required since the M87-1A3 was rail impact tested. E. The washboard. No damage, excessive amount of movement occurred within the trailer container with the twist lock during the testing. After the rail impact retest, the payload intermodal the container, the 15 mm separate loading projectiles, in addition with one of the pellet MK82 with the 500-pound bombs were secured against the bulkhead of the trailer. Ghost weight 45,189 pounds or 42,180 pound containers of the 15 MLSP plus 3,000 pounds for the MK82 bomb pallet. Testing data November 8, 2001. Photo 6. Trailer on the flat car railway impacting on the M87-1A3 trailer at the fully payload. Description: flat car CNW 780-576 for worthy 6,200 pounds. ISO container with the 15 mm SLPs. Additional MK82s with the pelleted number 500 bombs, 45,180 pounds. The M87-1A3 trailer 17,640 pounds. Total specimen weight 109,020 pounds. Buffer car 4 cars 25,000 pounds. Figures 10 and impact number figure impact number. The 1 average velocity 3.7. Impact number 2 4.5. Impact number 3 6.0 miles per hour. 4 impact 4 8.4 miles per hour, and impact number 5 8.3 miles an hour. Remarks: following the impact of the twist lock of the door, the end of the container of the driver's side jammed and will not return free. The reason for this explained previously. This did not affect the offloading of the container. The twist lock jammed. Following the reverse impact, the container removed to the 0.375 inches. And following the reverse impact, the impact of 1 through 4 was conducted with the rear of the trailer facility's direction. The impact of number 1 was lower average velocity due to the improper brake release on the specimen flat car. Impact 5 was conducted with the front of the rear trailer facing the direction of the impact. No damage, excessive movement occurred with the trailer of the container twist lock during the testing. The velocity data represents the average test speed during the testing. 5.3 test specimen M87-1A3 to the manufacturer fountain trailers, payload, bulk load with the pallets 15 mm SLPs pallets with a 105 mm box ammunition, gross weight of 33,940 pounds. Testing day November 6th, 2001. Photo number 7 shows the brake load of the M87-1A3, and also the photo number 8 shows the M87-1A3 trailer with the bulk cargo on a flat car. 8 shows the rail impact of the wooding stanchion used during the brake bulk loading testing, and also photo number 8 shows the M87-1A3 trailer loaded with the pallets of the 15 mm SLPs and 105 box ammunition flat car. The flat car number, the ITTX M972861, 78,000 pounds, pallets of 15 mm SLPs of 105 millimeter, done as 33,940 for the M87-1A3 trailer, 17,640, total special in weight 129,580 pounds, buffering for 4 cars, 2,500,000 pounds. Number 1 impact with 4.3 impact passes miles per hour. Number 2 impact 6.3. Number 3 impact 8.5 miles per hour. And impact number 4 8.3 miles per hour. Remarks: the following impact 3 where there was 0.125 inches of movement between the wood of the stanchion and the trailer plate. With the following impact 3 with 105 mm wooden boxes moved about 0.375 inch away from the bulkhead. Impacts 1 through 3 conducted with the rear of the trailer facing with the direction of the impact. With the impact was conducted with the front of the trailer facing the direction of the impact. No damage, excessive movement occurred with the trailer and the cargo during the testing. 5. The velocity data represents the average speed during the test. As to the course, photo 711 shows the M87-1A3, the trailer with the brake bolt category. For pass number 1, 29 seconds at 5.3 miles per hour. Pass number 2, 26 seconds at 5.9 miles an hour. Pass number 3, 25 seconds at 6.2 miles per hour. Four passing number 4, lapse time 26 seconds at 5.9 miles an hour. Remarks: no damage, excessive movement occurred with the trailer. The cargo tied down rings during the testing. The following pass number 2, the strapping board broke and the end gate started, but the collapsed load strap was tightened. The failure was not a result with the trailer design, therefore testing was continued. The velocity data represents the average speed during the testing. See the road trip. No damage, excessive movement occurred with the trailer, the cargo rings during the testing. The D, the E-panic snap testing was not required since the M87-1A3 was rail impact tested. H with the the washboard. No damage, excessive movement occurred within the trailer cargo tie down rings during the testing. 5.4 specimen M87-1A3, the manufactured fountain trailer payload ended opening the inner module container with the 15 mm SLPs with the additional 1 pallet with the MK82. 500,000 pound bombs were secured with the bulkhead of the trailer. The gross weight of 45,180 pounds, 42,180 pounds container with the 15 mm SLPs plus 3,000 pounds for the MK82 pellet testing data number 7 2000. November 7, 2001, photo 12, the rear chain tie-down configuration on the M87-1A3 with the full payload. A, the rail impact, the photo 13, M87-1A3, the trailer testing with the full payload with the chain down the flat car. The description of the flat car: ITTX 972-861, 78,000 pounds. ISO container with the 15 mm SLPs, additional MK 82,000 pounds of the 500 number bombs for 45,180 pounds. M87-1A3 with the trailer 17,640 pounds. Total specimen weight 140,000 pounds, 820 pounds. The buffer for 4 cars 2,500,000 pounds. 4 to 14 shows the wood stanchion full payload testing. Impact number the 1 4.1 miles an hour. Impact number 2 6.2 miles an hour. Impact number 3 8.3 miles an hour. Impact number 4 8.5 miles an hour. There are no damage, excessive movements occurred with the trailer. The tie-down rings twisting during the testing. Chains remained tightened throughout the testing. The impact 1 through 3 conducted with the rear of the trailer facing the direction impact. Impact 4 was in the front of the trailer facing the direction of the impact. 3, the velocity data represents the average speed during the test. Photo 15 shows the chain tie-down configuration toward the forward end of the M87-1A3. And also photo 16 shows the unloading of the empty M87-1A3 trailer on the flat car. Part 6, acceleration data, accelerometer data.